I can't think of anything funny to say. Physics lesson 11.1, Intro to Light. Alright, so first things we need to know a couple things about light. So light is a type of electromagnetic wave, and because of this, it does not require a medium to travel through. Light travels slower, however, when it goes through a medium which is more optically dense. So pretty much anything that is not air or a vacuum of space. Let's see, why is this thing not working? Being lame, so lame. Alright, so they're caused by vibrations with electrical energies. They are transverse waves, not compressional or longitudinal waves, so they're transverse. The amplitude of the wave, however, now instead of dealing with sound like we were doing before, it's going to deal with brightness. And they have both an electric component and a magnetic component. And those components are perpendicular to one another. So you have a magnetic field and the electrical. So one's going up, the other one's going over. Eventually, when we talk about polarization, we can talk about how we can split that apart. But for right now, it's good to know that there are two components, and they're perpendicular to each other. So if you were to give yourself the thumbs up, the fingers that you had curled inside, were to straighten those out so it kind of makes like a upside down L. That's your perpendicular, also known as the right hand rule. And we'll talk more about that later. Fun thing about light, it has a speed limit. It cannot go faster than the speed of light, which is 3 times 10 to the 8th, and that is shown with the letter C. Spectrum-wise, light can be separated into the known electromagnetic spectrum, which includes radio waves, microwaves, infrared rays, visible light, which going to go from infrared, which is below red, to red. Orange, yellow, green, blue, violet, no indigo. Can't see it anyway. Violet, ultraviolet, which is above violet. Then we get our X-rays and our gamma rays. Notice that the wavelength does change. So it goes from a really big wavelength over here to a little tiny wavelength over here. To help picture this, if you could think of a really tall building, like, I don't know, the Empire State Building, that would be one wavelength in a radio wave. Whereas a gamma ray, the wavelength there is about the size of a proton, so very, very small wavelength, which means it carries lots and lots of energy, and probably why gamma rays are so dangerous to us. Alright, so when light hits an object, one of 3 things can happen. The first, it can just go through it, right? Glass, plastic, cellophane, whatever. If it's transparent, light can just go right through it. Second thing is some of that light could get absorbed, not go through it at all, like solid wall, paint, clothing, stuff like that. And the third thing is it can reflect. And if you take a picture, that's kind of how color works. So we have all the visible light coming around over here, and this red Mustang, which is sweet, reflects off the red. Clear blue water bottle filters all of the color, letting blue out so that we can see blue. Alright, so that is 11.1, and we'll finish up with 11.2 in just a little bit. Hasta luego.